Gradle 8.1 contains some exciting updates. Here's an overview of the major changes.
One thing you worked on was improving the consumption of shared build services. The programming model for consuming shared build services was considered too verbose, and the contract for consumers requires them to declare a property to hold the service provider that they want to consume, assign that provider to that property, and also declare that the task uses the service. The last one is required so you can enforce parallel usage constraints that some services may impose. So that required a lot of code. And in 8.1, we introduced it's an experimental feature, it's not finalized yet. But basically now you should allocate your property that's supposed to hold shared good service with the service reference annotation, and also provide the name of the service you want to consume. Basically, that's all you need to do. And you get the service assigned to your property automatically. And also your task is declared to consume the service as well. So in 8.1, we finally promoted configuration cache to stable. So it was introduced back in 6.6 in 2020. And by stable, we do not mean complete. It's ready for general use, but we intend to continue to evolve it to cover new use cases and improve performance. Note that there's a stable configuration cache feature flag that we introduced to ease adoption. And that flag is still in place. So builds that don't have configuration cache enabled can enable it properly so they can get some hints of things that need to change to make their build compatible with configuration cache. Another feature that was promoted to stable in 8.1 was the ValueSource API, which is also configuration cache related. A value source is a way of a build declaring that depends on external data that's potentially changing. So the configuration cache is aware of value sources. It's going to always invoke them to obtain the value, but you only invalidate the cache if the resulting value actually changed. So even if the raw source may have additional changes, unless the value provided by the value source changes, the configuration cache should remain valid. So the classes and methods you see there are now considered stable. Next slide is about some core plugins that are now compatible with configuration cache. The first one is the Ivy Publish plugin. So basically, this is showing that in 8.0, if we try to use the Ivy Publish plugin, you'd get a configuration cache problems reported because it violated some of the requirements imposed by the configuration cache. But once we move to Gradle 8.1, we get to publish plugin. Similar demo here for the signing plugin, which was not supported up to 8.0, but now it's an attempt to use it in 8.0. Again, violates a few different constraints imposed by the configuration cache, but in 8.1, you get to use it successfully. Those demos there also relied on file system-based repositories, which did not work with configuration cache up to 8.0 as well, and now do work. A few other improvements. Up to 8.0, the configuration cache data was stored in disk without any sort of protection. So if there were any sensitive information, recommendations, or other things, they can be seen in the file system. 8.1 introduces a default encryption. It's the only way actually going ahead. Like you cannot disable encryption, so at least not at this time. So with the demo, of course, here in 8.0, we basically build a simple project and try to find the main class for that project in the configuration cache, and we do find it. So in 8.1, you can see if you try to find it, it's no longer findable because it's encrypted. One potential vector is accidental or intended sharing of the configuration cache area in continuous integration environments as a good artifact. So that's what was one of the main cases we're concerned of, that configuration cache could be shared. The next one is dependency verification, which will not work until 8.0, but it's now supported in 8.1. And this is only going to show 8.1 because there's a bunch of different things that this requires to work that did not work in 8.0 as well. So everything came together now. Basically, we're going to generate verification metadata for the project, and at first, then we try to resolve those dependencies And since the verification metadata matches the expectation, not everything works. But if you go and tweak the dependency metadata for instance, we are missing the metadata for some dependency, you're going to get a failure. And before which one that will not actually be detected. So that failure will go unnoticed. Now we should restore the verification metadata and try resolve dependencies again. We successfully validate that the dependencies are valid. Same thing if we change the version of the dependencies. Now the metadata we have is no longer valid, so it should be detected, which is now we can update. If you believe our dependencies are okay, you can update the metadata and now a check should pass.
We now support Java and Kotlin lambdas as task inputs implementation details. However, the usual restrictions still apply. Lambdas should not capture unsupported types like configurations or projects or Gradle script objects. So we have a simple task that accepts a Java single abstract method interface as its input, and the plugin sets its input to a lambda. And then Gradle 7.6 first run is fine because we are priming the configuration cache, but the second fails with the cryptic deserialization exception. In Gradle 8.1, we get first run fine and the second run also fine, and lambda is successfully deserialized on the configuration cache. I'm using Gradle 7.6 because this feature silently was shipped in 8.0, but we decided that it deserves a bit more spotlight. Another improvement in the related area is a better error report for Groovy closures, which accidentally write a Groovy closure as a do last action that references a project which is not supported with the configuration cache. You might be familiar with these kind of errors. Example, you have do last that calls project.exec, and the first run with 7.6 is again fine, but the second, when you restore from the cache, process could not find method exec. However, with the Gradle 8.1, error message is much clearer. It just says that your task cannot reference a Gradle script object, which is the actual root cause of it. In 8.1, we also shipped several improvements in what Java Kotlin Groovy APIs are recognized as sources of build configuration inputs. We added more file accessing APIs like methods of Java IO file class, like exists list files. So if you check at the configuration time, if the file exists on disk and make some decision based on this, for example, you configure the task differently before 8.1, this was not recognized. Creating the file would not invalidate the configuration cache, now it does. Similarly, we also recognize access, reading the file contents with the file.text in Groovy or file read text extension functions in Kotlin, and also a bunch of new IO2 methods in files and path classes. We also added the input detection for side jars. Previously, we were just skipping this. Another feature which is not restricted to the configuration cache, but we will introduce to support it mostly, is the Dataflow actions. Dataflow actions allow you to schedule some work outside of tasks. And with this, they are able to, for example, consume the result of executing the task. In 8.1, use of Dataflow actions is limited to the replacement of build finished callback, which is deprecated because it cannot be supported with the configuration cache. It follows the existing pattern of isolated build logic pieces like ValueSource or work action. It's a bit verbose, but provides all necessary isolation, and it's hard to accidentally reference something that cannot be used. You basically need to define a class that implements your action. It can have parameters. It implements flow action interface. And then in your plugin, you have to register the action, provide the parameters. You obtain the flow scope, you pass the class argument, and you configure the parameters. The Dataflow actions are ready to execute as soon as their parameters are ready. And if you specify build work result provider as an input, then this action would run as soon as the build finishes. Even if the configuration phase fails for some reason, the action would run and you will be able to process configuration phase failure. Of course, this only applies if the configuration phase proceeds far enough to actually register the flow scope. This API is fully compatible with the configuration cache.
Hi, so Gradle 8.1 ships with lazy property assignment for Kotlin. So maybe if you're not familiar with this lazy provider API, maybe it's time now that you check it out. But it's basically, the idea is that we wrap input and output types in some lazy types, normally like a property or things like that. And that gives us some nice benefits. For example, when we wire two tasks together, it's not important anymore which task is configured first and things like that. It's just important that we set these values and Gradle will take care of the rest. There are also some drawbacks. So then we get a bit like more verbose DSL. We now have to use this .set method everywhere, which is, maybe not that nice. Maybe we can do something better. And with Gradle 8.1, we can do that. We can now use just a normal assignment that you were used to, right? And this works with like constant values, normal row types, and also with lazy types. You can see that this file is actually a provider that is like a Gradle lazy types. And one of our goals was also that it works nicely with the IntelliJ and Android Studio, and so you can also check what is behind this assignment. You can see, it's just .set under. And lastly, this feature is not yet enabled by default, but you can enable it with this flag system prop or Gradle unsafe Kotlin assignment. You set that to true, and your build will be able to use the feature. One important thing for IDE to recognize that you enable it, it's important that you put it in project root Gradle properties.
So there was this problem for a while that you'd get a bad signal in the IDE showing that you should not use the libs or whatever version catalog name you're using. So in 8.1, we fixed that. So now it's working properly the way we intended at the beginning, and the IDE support is working now. We made also some improvements to standalone script compilations. So by standalone, we mean the build.gradle KTS files, settings file, init scripts in your project. We now show all the compiler warnings by default. They were only showed at lower looking levels before. So for example, if your build script uses some deprecated member, then you will actually see the warning in the console when that project is configured. So that will help you pinpoint problems. Compilation errors, when they happen, are reported in order now, in order as the file content that triggered them. And we also made a subtle change to disable the Kotlin compiler pre-release check. And disabling that check allows referencing Kotlin code, for example, a plugin that was compiled with a more recent Kotlin language version. Of course, if you use, if the plugin uses language features that are not available yet in the Kotlin embedded by Gradle, things will fail, most probably compiling. But at least we can support the use cases on a best effort basis, and it was asked by the community many times, so it's a good thing. And then we move on with more improvements to the Kotlin DSL plugin, and that's the plugin for writing plugins in Kotlin using our DSL. And the first thing we changed is that now it's properly published with licensing information in metadata, and that was also asked by community folks from companies where this was creating friction. With Kotlin 1.8, the Kotlin Gradle plugin on which our Kotlin DSL plugin relies started exposing the compiler configuration properties as Gradle lazy properties. And so in Gradle 8.1, we leveraged this to make it much easier for folks to further configure the Kotlin compile task in such projects, because before that, we were using after evaluate and do first internally, which was of course a bad smell, but it was getting in the way of users configuring their Kotlin compile tags. So that's now fixed. And still about this plugin development plugin, this is the one providing precompiled script plugin support. As a reminder, precompiled script plugins are .gradle KTS file, but stored in source sets to be published as plugins. And so there were a few tweaks to the usability there. We now only consider Kotlin sources when looking up those scripts, and that prevents confusing error messages when you add, for example, such scripts in your resources. We made some progress on how different error messages they are reported and more actionable, especially on invalid script names and stuff like that. And the process to generate type-safe accessors for these is now complying with the -- offline flag, and the output of the synthetic configuration that is required there is now captured and only reported in case of errors, so making the build less verbose and less confusing. The Gradle type now exposes that it is actually extension aware explicitly, so you don't need any more casting in order to access extensions or extra properties of the Gradle object. The test task has this forkEvery property. Now set forkEvery using a simple assignment.
For A1, we now support compiling and testing code with Java 20. Essentially, anything that uses toolchains works here. The one caveat is that Gradle itself cannot run on Java 20, since our embedded version of Kotlin does not yet support 20. Though future versions of Gradle, which embed newer versions of Kotlin, should fix this. CodeNarc tasks execute in parallel now. We did this for PMD and checkstyle in previous versions, but now the CodeNarc plugin and task uses the worker API, which allows us to release the project lock when executing CodeNarc, meaning that other CodeNarc tasks can run in parallel.
This Gradle version, we are introducing a small feature for the wrapper task that can help you simplify your Gradle upgrade process. From now on, you can also use 4 different labels to determine which version of Gradle you want to be used in the Gradle wrapper. The latest label for our latest official release, the release candidate label for our latest release candidate build. Keep in mind this can actually be older than the latest release in case there hasn't been any release candidates for the upcoming version. The nightly label for the latest nightly build from our master branch, and the release nightly label for our latest nightly build from our release branch for the next upcoming release. I'll now quickly show you how this looks in practice. As you can see, it's Gradle version 8.1. Now I can use the latest label to get to our current release. And as you can see now, it's 8.1.1. And I can also use the nightly label to get our latest nightly build. And as you can see now, it's our latest nightly build 8.3 from yesterday.
We made some changes to the Build Init plugin so that when you opt in into incubating features, we actually enable parallel project execution and the build cache in your generated project.
We've enabled one feature to mark Gradle cache directories with the cachedir.tag specification files. This is useful for things like backup utilities, so they're aware that certain directories created by Gradle are kept for caching and shouldn't be backed up. Workers will make sure that there's enough free space when a new Gradle worker process is created, and it'll shut down old workers in order to free up that space. We made a change to ensure that the maximum memory for a given worker is available on the heap as opposed to the minimum in order to improve worker scheduling.
Our team made several improvements regarding Gradle plugin portal. First one is feature flag for publish plugins task, which basically allows you to validate your plugin setup before actually publishing it. It does everything that a regular publish plugin task does. Another feature was implemented is about 6-store sign-in support. So basically, folks who use 6-store bundle files are no longer need to sign up
were plugged twice with SigStore and our signing. And so it would be basically improve process in terms of not signing everything twice. Another thing is fix of shadow plugin integration. So basically we polluted jars and manifests to contain Gradle API jars, internal jars, which is, with this fix, it's no longer the case. And we also made several improvements regarding documentation on approval process with public documentation as well as internal documentation. And we hope it would make the process more transparent to our wonderful contributors and ourselves as admins of Gradle plugin portal.